In this session, we are going to learn about test-driven development using Golang. We will be looking some best practices of it and how we can start working on TDD on our company's project, or either we just starting to practicing it out. All right. So, who am I? I'm Mohammad Quanit. I'm working as a product engineering manager at TimeGram.io, which is basically a SaaS-based startup. Basically, calculates or manage the time for freelancer agencies. Also, I'm a AWS community builder as well. Along with, I do write technical content on dev.to, which you may probably have heard, and I also do some public speaking as well. And these are my hobbies that I mentioned. Okay, so let's see our agenda for today's talk. First, we will be looking test-driven development, what actually test-driven development is, what should we do, how should we care about, and what is basically the motivation for it. And then we will looking some ways to test in Golang, to write testing in Golang. There are some approaches that I've already mentioned in this list. Go testing package. We'll be discussing about HTTP server, REST API testing. We'll be looking at some table-driven testing, which is basically an approach for writing test cases in Golang. We will be looking some open source testing framework that you can use, and at the end of our talk, we will be looking some TDD best practices. And after that, we will be concluding our talk. Okay, so TDD, what is TDD? You probably have heard of TDD as a most hyped term. So TDD is nothing but just a software development process that involves repeatedly writing test cases first and then write actual code. So basically what happens that traditionally developers did was whenever they write a software, whenever they write a feature in a software, they probably write some code first, and then after that they actually start implementing test cases. But there's a high chance that developers or engineers can miss some of the cases that actually that feature contains, right? So for that issue, for that problem, test-driven development is an approach that introduced by some of the early engineers in early 90s, that why you shouldn't write test cases before actual development. So this is what test-driven development is. It actually forces the developers in terms of implementers or users. So basically, when developers are writing test cases before writing actual production code, they know that okay, so this is a feature we need to cover this amount of cases, and then if all our cases are covered, then we can start writing our actual code. So by writing test cases first, we developers can catch errors early in the development process and ensure that our code is easy to test, maintainable, and refactorable. So what does it mean by that? Okay, so if developers are required to write a feature for their application, what they can do is they can first assess all the test cases that could cover the actual feature. Then they can start writing the test cases, and if after writing test cases, or after their writing production code, they can catch errors early in the development process. So if somehow things are breaking in production code, so what they can do is they can actually check in test cases, like what they did miss, or what they have done wrong, or what could they have done wrong, right? What could they have done wrong? So that's how they can ensure our test cases are easy to maintain, and after that, when they maintain, it's easy to refactor as well. Test-driven development approach also helps engineers to write better code and reduce time on debugging. As I said above, if developers are able to catch errors early on development time, on actual production code, they are able to reduce the time on debugging, because they knew that they actually wrote test cases first, and they knew that where the error could occur or where the issue could happen. So it eventually reduces time on debugging part, and this can lead to more predictable and reliable software, as they are already reducing the time on debugging. And the last part is that TDD is not just part of like merely testing mechanism. it requires a lot of practice to be honest, to implement in some real world projects, because it's not just like that you start writing test cases before and then after you write production code. You need to be mentally prepared that okay, so if I need to write this feature, what are the test cases actually cover? So it requires a lot of analysis and assessment of our feature that we are supposed to deliver, and then we have to discuss with our lead that okay, so what are the things that this feature can cover or should not cover, and then according to this we need to write test cases according to it. So it's basically a like mental model. If you go along with the at first it will be overwhelming, but if you are doing practice with your side projects or any small scale projects, you will be good to go in TDD burst, because it's like just a mental approach for writing proper software. Okay, so TDD has some stages. The first stage is when we write a test case, we need to write a test case. Okay, so after writing the test case, we need to check the test case. Okay, so if we have some provided, if we have some road in test cases, let's say if we are testing some function that actually testing or some function that takes numbers and incrementing them, we need to verify that okay, if we are providing this number of this length of numbers, then it could result this. Okay, and we will see in live code as well. So after writing our test cases, we then need to write our production code so that we can actually run our tests by our production code. After writing our production code, we can run or we do run all our tests. If things are good, we actually clean up our code or refactoring our code. That if this is required, if both test cases, if both refactoring required in test cases code or the production code. All right. So this is the stages of TDD. Okay. So why should we even care about TDD? Okay, so first point is that it shortens the programming feedback loop. Okay, so what does it mean by that? Like it reduces the feedback time. Let's say if there is something, if there's a requirement of a feature and you have already wrote a test case of that feature. After writing the production code, all things are well in work, but suddenly there's a change required in that feature, you can easily go through your test cases code and then you can actually update it, because you don't need to write the whole test case again for that feature. You just need to maybe tweaks in your test cases code. So it actually shortens the feedback loop of your basically requirement for your test cases. As I said above, it also encourages engineers to write modular, testable, and maintainable code. Modular in the sense like if I have an XYZ feature and it consists of let's say 5 steps, we can write 5 separate test cases for the specific feature, which we can wrote it in a test suite, and we can test it via separately. So we can test those 5 steps separately in a modular manner. It is also testable, and if we write our test case in a modular form, it is also maintainable as well. It also helps catch errors early in the development. It also reduces debugging time as well, because if you know what you are doing actually, and there's some issue happens in your production code, you know where to look at your test cases, and then you can fix out your actual time. It also reduces the cost of change. Let's say if there's something new requirement in that specific XYZ feature, you can also change the test cases along with that feature, and then you can just probably add some edge cases that feature actually was supposed to cover, right? So yeah, it also boosts confidence with sense of continuous reliability and success. So as a developer, when you are writing test cases, you know that all right, you have done your part in terms of testing, so and you have covered all of your cases, so it helps you with the sense of reliability. Okay, so I already wrote this test case or those test cases, now I'm good to go with this feature. if there's any issue occur, I know where I have to debug. I have to look at on our test code. And if you don't write test cases, how do you know that your code is doing the right thing, right? If like test cases, it should be mandatory for every company. Uh, in our company, we are also doing some like test driven development. Like we just started in our company like TDD, implementing TDD in our project, and so far is going good now. So because we know that whatever feature we are supposed to ship, we know that it will supposed to work. It will work. And if there's any issue comes up, we know where we have to tweak some changes in our test cases. So these are some motivations that we should consider when implementing TDD, because it helps you to focus on your path. That okay, so you are doing TDD for this purpose, and it will pay off in long term of time. Okay, so let's see some of the testing, some of the packages in our Golang. So the first and the foremost testing package actually provided by Go. So whenever you install a Golang environment in your computers, you actually get testing package along with it. So Go testing package is a built-in by default testing package that comes with Go environment. It's basically a command line tool that automates the process of running tests. Okay, so whenever you write test cases in Golang, you wrote test cases, right? And then how then you have to run those test cases. You provide a command called go test, and then it will actually run all the tests which you are which you have written code of, right? So we will see it in an example as well. So test functions with a specific. So whenever we write test cases in Go, we need to provide with a specific signature that must start with test. Okay, so whenever we write test code, let's say we are writing a test for our feature XYZ. So the file name should be our XYZ underscore test, which takes a pointer, and then we then create a function on it, and then it takes a pointer testing.t, which is basically a struct that actually provides some of the methods and properties that we can use to write or assert test cases in well. Go testing package comes along with testing coverage tool as well, that can actually help you to generate coverage report, which shows how much of your code is covered by tests. So let's say if you have write 20 test cases in your project, and you want to see the coverage of your test cases, maybe it could be 80% or 90%. So you can use the Go coverage tool, which can actually generate and visualize the coverage of your actual test cases. It also supports benchmarking as well, which is used to measure the performance of your code. So let's say if you are writing an HTTP server, and if you want to benchmark the latency of the REST and server or client to database connection, you can actually benchmark that as well. Not just HTTP, not just REST APIs, but in fact some whatever you are writing. So you get a point. And it also comes with support some of this flags as well. As you know, Golang supports some flags. We can provide some of the flags to see the more detailed logs in our test cases. Like we mostly use -v flag, which is basically purpose flag, which is to show the more logs in our test cases, or the behavior of our test cases, how our test case going, or what is the behavior of our test cases are going. Go test package, as I said, are written on a file ending with underscore test.go, and every test function is start with test keyword, which takes a testing parameter testing.t pointer. That's basically a struct. So let's see here on a live code. Okay, so as you can see here, we have a file called main.go, and where we have written two functions on it. One is hello world, and other is sum. So we will see the test cases of both of these two functions. Let's see on our main underscore test.go, which is our test cases file. So let's see our test hello world test cases. So as you can see, as I said before, that whatever function we have to write for run our test cases. The convention for Golang testing is the function should start with that keyword test. So we have two variables. One is God and one is bond. And if for some reason God and bond is not equal, our test case will be failed. Same as for test sum function. And as you can see as well that we are providing a parameter testing.t, which is basically a struct that provides some common methods of interfaces and function and properties. So if you see this test function, so basically test function, the sum function is taken a number array of numbers, and then it actually runs loop for loop on it, and returns the sum of all the numbers provided in our arrays. And we have written our test case for test sum as well. The d.run function is basically supposed to run our test case and in a separate thread. So if I write another t.run in our test.sum function, it works in a separate thread. So for now, for the sake of this example, I will just run a single t.run function, which basically tests our sum of numbers in an array. So the numbers of arrays that we have provided here is 5, 4, 3, 2, 1. That makes it that basically the sum that 15 will be the sum of this function when the sum function returns, and the one value contains 16. So somehow it should fail, right? So let's check the. Let's see the how we can run our test case. Go test, and if I provide /v flag, it's basically providing me enough information to see the steps on our test case. So if I click on it, and you can see here that my test string function has been passed. Test case function is passed because its hello world function is written exactly the same string as I provided in what variable. But my test some number of arrays to test some function has been failed, because we are getting the result in this function is 15, and I'm asserting the value of 16. So it actually fails because it's just t.error of function run, which is basically a log f to print the logs that your actual test case has been failed. To see this on terminal basically. So that's basically how you write test cases. HTTP testing. So testing an HTTP server in Go involves some sending HTTP requests to the server and verifying the responses that it returns. So whenever we create an HTTP server in a form of REST endpoint, so what we need to check is that if our data is coming out in a proper manner, or the length of our data is coming correct from the server, or if we have to check some status codes. So there are some examples that we can test on HTTP server. So let's see on the code. Okay, so here you can see that we have a file called endpoints.go, and I've already wrote two functions on it. One is get posts, that is basically returning all the 100 posts that's coming from this API endpoint, this public API endpoint. And we have written along with a header and some status code. Okay. And we have another function called get single post, which takes a parameter and then it will return a single post on the basis of an ID. And if we see the main function, which is HTTP example, which we are calling in our main.go function, main function in Go environment. So you can see here the endpoint.http example. So if we see this function implementation, we can see that we have provided a port. I'm using the Mux new router to set up the routes for my API. I have set it up two routes, one for posts, one for single post, along with the ID parameter. And I have did some logging to see the actual log for our server. And I've already up and run the server. So if you can see this, I've already started server on port 3001. So let's see the test cases of it. Okay, so I have created a function called test post endpoint, which is supposed to test the endpoint, which is supposed to test the endpoint. Test endpoint. That's as I said that it takes a testing parameter t, testing.t struct. In a parameter, we are creating a new request, which actually hit the request and post. The new request is something. The new request basically runs with the context.background, and it which helps us to generate a new request on the specific endpoint, which is next post in our case. And we are getting it our get request. And if there's an error, we can see an error. So what actually we are doing here? So there's something called HTTP test, which is a package comes with Go environment, and we are using the new recorder function. So basically, this function is an initialized response recorder. So it is the implementation, it is the enhanced implementation of response writer. So if you have ever worked with REST APIs in Go, so you have used response writers most every time, right? So there is something like there is something on top of response writer, but it is basically a response recorder that helps us to record the response. Uh, we then created another variable called handler, and we simply provide the handle function, which is basically getting this get post. So get post basically the function that we have implemented for getting our all the posts, right? So again, we go to our test function. We are then serving our HTTP, because we need to test our endpoint in such a way that it can actually run the endpoint and get the response from the actual API, and then we are going to look at the length of the response that we need to verify. Okay, so I then did all this stuff, then decoding and encoding stuff for converting data into struct. All right, and then we have created two variables: got expected length and want expected length. Okay, so this API, that the post public API, is supposed to return array of object of 100 objects, right? So so I want to verify that if my API is returning me the length of 100 objects in an array, and we are checking with got expected length that what actually the length of the data is getting from the API endpoint. So then simply we just did if condition, and if somehow our length does not match, it will fail, right? So if I run the terminal here, I go to CD server, and I run go test HP. If you can, so you can see that my tests are passed, because now how it's passed, because the length of the data which came from the API endpoint, the post API, has 100 items, and I want to check it with 100 as well. So let's say, so if I want to see the failed version of my test case, so if I provide 101 and I do this, and if I run again go test V, you see it will fail, because the unexpected length of data got 100, want x1. Because I want the length of data to be 101, and I am getting the length of the data is 100. So that's how you can actually write HTTP test cases. Another one, like, you can also check some status code as well, if you want to see if this API, if this response of this API is getting 200 OK server, or if you are trying to check some other status as well, or if you are if you are finding out that if this API comes with some data that I am expecting with this specific field. So these are some of the examples that we can cover in HTTP, but for the sake of this session, I am just showing you this example for HTTP test. So the main crux of this HTTP is basically we basically use the new recorder. So with the new recorder is basically like we get all the properties and methods which comes in response writer when we create some API, HTTP API. All right. So let's move on to our table-driven testing. So table-driven testing is basically allows you to test your feature or function with multiple inputs and expected outputs, right? So what basically means that if you see this example, let me show you. So here we only created got and want variable. If you remember our first test case, we only use got and want variable. But if we want to check multiple, but if we want to test our feature according to multiple use cases, then what we can do here is, let me show you the example. So there is a simple sum function which I created that is simply returning a plus b response. And if we go to the test function, so you can see here the test sum, and you can see here that I created a simple struct named cases, and I provided a description, num1, num2, expected. So what basically does is that I can create as many as use cases as I want for testing my sum function. So let's say if you see the first two objects basically, so here I am providing the description 1 plus 2 and num1 and 1 plus 1 2, and expected will be 3. Okay, so if we add 1 and 2, 1 plus 2, expected should be 3. And if we provide 3 and 4 input, like num1 from 3 and num2 to 4, expected should be 7. So you can see that we have created a struct along with and then we ran the loop on our struct cases by using range keyword. Now, as I said before, that t.run is basically responsible for running our test case, right? So here we are providing t.run, and then we provide our t.description, which is basically the text that we are supposed to see on terminal. Then we have provided a function that is getting testing.t, which we already discussed, and in this loop I am getting the result of sum, and I am providing the parameter num1 and num2. So on the loop side, in the loop we are getting num1 and num2, and for each of these cases, like for case number 1 and case number 2, it will return the response either our test case is pass or fail. So if I run my code, let me clear the screen. I go to cd and table. So if I run code test actually. Okay, so as you can see that in our verbose method, verbose flag, we can see that we have run a couple of test cases, 1 plus 2 and 3 plus 4, and all of them are passed. Okay, so now you have the idea like table-driven testing, what table-driven testing is. So table-driven testing is basically an approach where we actually provide as many as use cases, as many as inputs, to get different outputs. So let's say let me add another one, input, and let me do this 10 plus 45, and I provide number 1 and number 2, 10 and 45, but I'm expecting, let's say, 70, which is not basically, which should be failed, right? So if I run this test case again, we can see that our test sum 1 plus 2 is passed, test sum 3 plus 4 is actually passed, but 10 plus 45 has actually failed because we actually wanted the number, because we actually wanted the expected is 70, but we are getting 10 plus 45, which is 55. So that's how you can provide as many as input as you want and get different outputs according to your use case. Alright, so you got the idea of table-driven testing. There are some testing frameworks already provided by Go community, in which you can see the Go Mega, which is basically a match assertion library. So if you have some advanced level of assertion and you want to test some complex use cases that require some matching feature, then you can go with Go Mega library. Another version GoCheck. Basically, it's a feature-rich testing library which includes that more advanced and complex features. Testify toolkit for mocks and assertions. It is also similar as Gomega, but it also provides you some mocking feature to provide some fake data or fake responses, I should say. So GoMock is another dedicated framework that you can use to test your actual code base. And there's another one called Jinko, which is basically a BDD testing framework. BDD stands for behavior driven development. So it's like something where we have to check specific specs. So basically it's mean like we can see the behavior of our code in a form of specific specs. Okay, so you get the idea of so you see there here are testing framework that is already introduced by Go community. Okay, so the main thing to follow is like whenever you are working with TDD, you need to follow some best practices, which which you should basically. So the first and foremost, which I already discussed as well in early in the start of my session, that always write test case before the actual code, because whenever you write test cases, you know what you are actually supposed to do in your actual code, right? Write a small and focused test. Okay, so if you have a feature that contains some different sort of that perform different sorts of algorithm, you can write a small and focused test of that feature, like test for algorithm 1, test for algorithm 2, and you can set it up in a specific suite. So make sure to write small and focused tests so that it can be easily manageable and maintainable. Use go test command to test case along with v flag for verbose logs. So as I said, as I show you in the terminal, as I show you in live code, that always use go test for testing your go test cases. Use mock dependencies to simulate actual behavior of the feature. As we see in our table-driven testing example, we use mock inputs, right? So not just inputs, we can also mimic some dependencies to simulate our actual behavior that our code have to follow, right? So yes, so basically you can use fake dependencies as well. Utilizing code coverage tool, as I said in my starting of the session, like always use go test cover. So basically if you want to see the coverage of your test, you can use go test cover, which is basically a good thing to do along with when you are writing your test cases. Automate and refactor your test cases using CI tools. Okay, so after writing your test cases, make sure after time to time you are updating your code or you are refactoring your code, because at any given time that feature got some changes, or client has some requirement that okay, we need to do something this and that, or we need to do some replacement, we need to do some replacement, or we need to some add or remove things. So we need to have our test cases along with our code. And if you are deciding to automate it, it will be a great practice to do it. You can use different CI tools like GitHub Actions, Travis CI, Jenkins, etc., etc. Always keep your test cases up to date. As I said, always keep your test cases up to date. You may not know that any given time requirements get changed, so you make sure that you are already up to date in your test. Already update your test cases along in the context of feature, or even if you are using some external framework or library, you need to update that as well, so your tests do not get break in the actual runtime. All right, guys. So thank you very much. So this was my session, and thank you. Conf42 Golang team for having me here, for inviting me to talk on this. You can follow me on Twitter at Quanit, GitHub, LinkedIn, where I'm mostly active on. So let me know if you have any question. You can reach me out on the social media, and thank you.